Alright, here's an example from the notes, but let's work it out slowly. It has the limit as n goes to infinity of e to the 2n plus n divided by 3e to the 2n minus 5. So our theorem says that if this limit exists, we can say it's equal to the limit as x goes to infinity, and we just replace every n with an x. All x's everywhere. So the reason that this works is that these function values are dots. We have to plot them as dots, but all the dots land on these function values, which is the smooth curve. And since it's a continuous function, we can handle that. That'll mean that is wherever the curve goes, so will the dots. And the fact is that we often can do that step in our heads, because as you're taking the limit as x goes to infinity, all you did was rewrite the original problem. So you can often just look at the original problem and treat the n as if it's a continuous variable. Because that's what we do here. We treat the n as if it's an x, and now we try it out, and plugging in infinity gives infinity plus infinity over infinity minus 5. We're getting infinity over infinity. And that lets us know that we should be able to use L'Hopital's rule. There. That means we can say this is equal to the limit as x goes to infinity of the derivative of, separately, the derivative of the top and the derivative of the bottom. Not the quotient rule. This is when you get to take the derivatives on top and bottom completely separately. So on top we have 2e to the 2x, because e is its own derivative, but then the chain rule brings down to 2, plus 1. And then on the bottom we have 6e to the 2x, which we're getting very close, but still getting infinity over infinity. And so we have to do it one more time. L'Hopital's rule again. Another L'Hopital's rule. So this time I'll have a 4e to the 2x on top, plus 0, and I have 12e to the 2x on the bottom. And now it looks like infinity over infinity, but it also, we notice that there's a common factor of e to the 2x. So we can cross those off and get this, the limit as x goes to infinity of just 4 over 12. Now that's a constant, and whenever you take the limit of a constant, you get out the constant itself. Does reduce to 1/3. And you could almost see that answer from the beginning, but a lot of times when you have e to a power, there will be examples where the power is a little bit too hard. It doesn't just bring down a 2 every time like I did on this one. It might bring down something more complicated, and so it's a good practice to actually do the L'Hopital's rule to figure these out. It might not be immediately visible like in your head from the beginning.